Well, good evening, ladies and gentlemen. We're coming to our last presentation on the Festival Hall stage today, and I'm delighted to introduce Matthew Penrose from Vector Foil Tech, who's going to talk about ETFE, an extraordinary material which has been around a lot longer than many people think. And he's pointed out to me that there are 5 shortlisted projects at WAF 23 which use the material, which have been presented or being presented today and tomorrow in the crit rooms around the hall. So without further ado, I'll hand over to Matthew Penrose. Hi.
Hi. Good afternoon, everybody. Welcome. Welcome to our presentation on ETFE building envelopes. So I want to start with what is ETFE? Ethylene tetrafluoroethylene. Very simply, it's a fluoropolymer. It's not a plastic from the petrochemical industry. It's one of the good guys where its core materials come from minerals. And this is the Joule project. And being a fluoropolymer, it has no problems with fire, sustainability, UV, or longevity. Now, the material has been around a long time, developed in the 40s by DuPont, and it's been used in many industries since. But it was our founders 40 years ago that took ETFE and brought it into the construction industry. Now, an ETFE system is largely 2 layers of ETFE, welded at its perimeter and filled with normal air. That air gives it shape, gives it strength, gives it high thermal performance, and critically, everything is super lightweight, which leads to low carbon footprint, low energy use. Now, again, I just want to explain the system, and then we'll get into some of the projects. When you look at the underside of an ETFE system, it's very similar to giant curtain wall panes of glass. You have the ETFE fixing at its perimeter into an aluminium frame. Typically, the only way you know it's ETFE is there's a small inflation pipe in the corner. And if we've done our job well, you can't even see the inflation pipes. And here's a view from above. And the aluminium perimeter frames fixed to cleats, which are welded to the steel. The system is lightweight, but it's extremely advanced. It's airtight, watertight, allows for extreme thermal movement, plus there's a secondary drainage channel. And here's a video going back over about 23 years ago, I believe, showing how strong ETFE is. As we said, it's lightweight, but it can bear 400 times its own weight. There's a young Kevin McLeod, who you might recognize from Grand Design, interviewing Ben, one of our founders. And how ETFE works is when you put the load onto the cushion, the load can share. It can move, it can push that load around the actual cushion. While if you did that with glass, of course, it's going to crack and fall right through. So ETFE is used in countries with typhoons, hurricanes, extremely high wind loads. I'm not going to talk about single layer system, but we have a system where there's just one layer of ETFE, and the air that's used to support the ETFE is now replaced with cables. So projects we're probably most famous for the 2008 Olympics in Beijing, the Beijing Water Cube. This is currently the largest ETFE clad building in the world, about 100,000 square meters of ETFE with about 7-meter diameter cushion on average. What most people don't know is it's a double layer. You have an external layer of ETFE protecting it from the harsh conditions in Beijing, and the interior is also finished with ETFE to protect it from the harsh conditions of the chlorinated water. Now, a project we're just mentioning, you'll hear a lot more of this next year. This is the next biggest ETFE project in the world, King Abdullah's Gardens. It's currently ongoing, but ETFE is in one of the harshest conditions in the world, making plant growth, allowing human comfort, but more details next year on this. I think one of the most selfie projects probably before COVID, Hudson Yards. Hudson Yards is the largest private real estate project in US history. And you have the Heatherwick vessel here on the right. And on the left, you have the shed. And what the shed is, it's a telescoping building that doubles the footprint for large-scale events and performances. And of course, it's the ETFE's flexibility and lightweight nature that allows this to happen. We don't just work with engineers. We don't just work with architects. We work with people like Disney Imagineering. This is at the Tron Ride in Shanghai. And again, if you can imagine, that's a 6,000 square meter canopy. What else could do it? What could form that shape, give you a lightweight structure, keep you from the heat, keep you from the rain, have a daytime identity, and still transform at night? And this is really pushing the envelope of what ETFE can do and what we love to see architects challenge us with. And what you're seeing here is the ETFE in the day, and we have a print there which is cutting the glare, which is giving you thermal protection. But that same print at night becomes a projection screen. And you'll see ETFE projects at night, they radiate light and they glow. I just wanted to do a local project I saw recently, and I just reminded how wonderful ETFE is. This must be 12 years old now. This is City Hall in Korea. And these giant free sort of Zeppelin balloons, almost 6,000 square meters of ETFE, every cushion a different shape. And you go up into them in elevators, and there's libraries and cafes and offices and entrances. And it even protrudes out the end of the building and forms a viewing platform just at the end. So because we're in Singapore, I'm going to talk to you about some of the key projects here, and I hope you get to visit them. They are wonderful projects. Singapore Sports Hub. This is the stadium. It's the largest spanning dome in the world, about over 300 meters. And on top is a 20,000 square meter moving roof. And you'll see the image. It takes about 20 minutes to open. And what's unique about it is it's also Singapore's largest flag. It's also got 20,000 integrated lights on the roof, which allows the whole stadium to come together as one event. So all the lighting from the actual stadium can move into the roof itself. And of course, it has a natural grass pitch, so certain times of the day, the roof opens to allow all the necessary light to hit the grass. Clarke Quay, this is about 20 years old, and it was originally designed by Alsop, an amazing design. It transformed that part of the Singapore River. The area of Clarke Quay at the time was very quiet, very dead, and literally this regeneration project, you could almost call it, for Capital Land, took all of the traffic, all of the entertainment venues around it, all suffered almost immediately for the next 15 years. I'm going to talk about this project as a case study towards the end. It's recently had an enhancement program. For facades, now the video isn't running on this. It's quite hard to believe what this building is. This is a real image. It's a 15-story luxury car vending machine. You sit at the bottom and say, I want to see the Ferrari on level 10, and it comes down to you. And it's absolutely amazing. It's become one of the main marketing icons. So lots of companies are using the giant screen, the lighting to have marketing events. Fortunately, this video wasn't running. You would have loved it. Project Jewel, the $1.6 billion sort of integrated airport project. It's a nature-themed shopping mall in the heart of Changi Airport. It links together with terminals 1, 2, and 3. And right at the heart of it is the world's largest indoor waterfall called the Vortex. And right here at the heart, a 12-meter wide ETFE canopy, ETFE cushion. And even the drop-off canopies are all ETFE. And I know this details look simple, but anything with Safdie architects looks simple. You know it's incredibly complicated. Really a beautiful structure. Now, again, I'll be talking about this project as a case study at the end, Sabanager on campus, which is also shortlisted here at WAF. Quite an amazing project. If you've come with families, maybe your children are at Universal Studios now, down at Resorts World. This is the largest ETFE project in Singapore. 25,000 square meters of ETFE of every shape, form, print you can imagine. And the key for Resorts World was to keep people moving 24 hours a day. So all of the canopies link all of the key parts of the development. So whether it's too hot, whether it's raining, people will always move. And they learned a lot of lessons from other places about how when it's wet or it's hot, people stay in their rooms and they're not enjoying themselves. Again, Universal Studios. So as soon as you walk in Hollywood Street, what we've done here is to keep all of the focus on these themed facades. We've actually used the ETFE as a ceiling. It's a roof cum ceiling, hiding the steel trusses, so all of your focus remains on all of the themed areas. Now, this is the world's largest preschool, or it was when it was built. 2,100 spaces for 18 months to 5 years old. And every single breakout space was covered in ETFE because we could control the UVA, UVB. There was a lot of worry here about children playing and getting sunburnt. And every area we could help ensure that there was human comfort and the children were in the best place for education and play. And really nice project by Lend-Lease, Paya Lebar Quarter. And the reason I've shown this is the patterns put into the ETFE. It's down in the Malay community area, and that pattern is part of their heritage, and it's put into the ETFE, but also into the facades itself. Okay, so let's think about different sectors of the construction industry. Where can ETFE be used? So again, facades, what I showed you earlier, rooftop gardens, entire facades illuminating at night, and again, having that nighttime and daytime iconic characters. And they don't have to be big. We can also do highlighted areas like here at the Pavilion in Birmingham, just that main entrance to break up that facade. Moving on to high wind load seismic areas. So a lot of people think lightweight. How can we be using ETFE? We do a lot of work in Hong Kong, Macau, Taiwan, Philippines, which all have incredibly high typhoon loads. So this is a project we've just finished in basically along Manila Bay. Part of our scope was actually to do the wind testing that was done by MEL in Melbourne. So this is basically our design with the roof and hundreds of pressure sensors. But what this allowed the developer to do was to get, one, the lightest loads possible for the design of the roof, and two, discover if there was any hotspots of wind along that development, simply change the angle of the roof and eliminate it. So this is a project where we designed and supplied the steel work as well. Now imagine we're getting close to 40-meter span, wind loads of 3-4 kPa, so 300 to 400 kilograms per square meter, and no trusses. So what we're very famous for now is as much the ETFE, but also the lightweight steel engineering. And what they also did very simply on one side of the steel, it's not inside the cushion. It's literally just on the side, a simple strip of LEDs lights up that whole thing. Very simple, and this was a couple of months ago during the opening ceremony. Now, what happens during these very high wind loads? Does the ETFE bounce around? Well, on a microscopic level, it is bouncing. You're not seeing it. This was taken by the developer of Parcal. He was so happy during these amazing winds. He was seeing the form of the roof completely there in these high wind loads, but no movement of the ETFE. Now, we don't just do big buildings. This is a lot of people from Hong Kong. The amount of times I show this image has been there 10 years or longer, right next to Pacific Place, and they've never seen it. Amazing design by Heatherwick Studios, and Hugh Dutton was helping on the engineering. And what it is it's called the ink splat, which probably makes a lot more sense now you look at it. And it's contoured steel, forming the shape. So when you're inside, it's a restaurant, and you look up and you see it contouring up to the roof. And for us to make this, it's one single cushion. And this was doing the final checks and the final tests in our factories in Germany. Really amazing feats. Stadiums, big part of our industry. Long span is where ETFE you can really take advantage. This is the first fixed grass pitch with a fixed ETFE roof and facade. So ETFE is known to allow full plant growth, and it's demonstrated here. And this is Holland's largest stadium, and we added, because the ETFE is lightweight, a lot of stadiums are being retrofitted, and often with ETFE roofs or facades. 2,500 square meters, very little structural reinforcement. The stadiums, the roads stayed open. All the prefabricated steel installed, then the prefabricated ETFE, and a concave building became convex. I think retail is probably, and stadiums are really where you can show off the ETFE. This is, if you go to Kuwait, there's only one place you're going to go, the Avenues, developed by Malbani. I think we're at 117,000 square meters of ETFE over 4 phases of construction. Now, Kuwait has the extreme high weather we all expect in the Middle East, but it also has some of the worst sandstorms. So the developer really likes the ETFE because it's basically a non-porous surface, a bit like Teflon. When the sandstorms come and blow away, the roofs are clear, while the glass roofs are all still full of sand, which then they have to go and often manually remove, but not with the ETFE. And again, the whole theme of the Avenues is basically a city within, or cities within an ETFE building envelope. Public spaces, this is again is here in Singapore. It's called our Tampines Hub, and it's about taking all of the community venues you need, a library, futsal pitches, swimming pools, council offices, and putting it into one single vertical building. Really quite an amazing project if you get a chance to visit. This was a famous Hong Kong actor came down to open. We're doing a lot of transit buildings. This is the first LEED Platinum transit building. It's called Arctic. If you were going down to California to Disney, you'd probably start maybe here. And what you've got here is 4 private and 4 public forms of transportation, all put into a single building. You have this amazing ETFE roof cum facade, which again has lightened up all of that steelwork. and it transforms through day and night. So in the day, you've got the silver prints reflecting the heat, and at night, simple lighting on the steelwork, those dark prints basically become translucent. And your building not only becomes a beacon, but it allows you to look back into that building that you couldn't see during the day. Now, I want to get into a little bit of the technical. I've talked about inflation of the cushions. So how does it work? Have we got some giant blowing machine inflating these cushions? We don't. That little box there, size of a suitcase, is inflating all of that ETFE in that picture. So that's about 1,500 square meters, and it blows up to about 220 pascals, give or take, which is basically breath pressure. The system inflates to this pressure and then goes to sleep. Then if pressure goes down to a certain amount, because air always escapes, it switches back on, tops it up. And of course, it's a very German system. It's fault tolerant. So you don't just have one blower, you'll have two. You don't just have a computer monitoring the system. If that broke down, we have manual systems to take over. But basically, it's a small box. Most of our clients forget about them. It's quiet, silent, efficient, and it's doing all of the work, inflating those cushions. They probably cost about $1 a day to run. The power consumption is the same as probably one light bulb here. Now, ETFE by itself is completely transparent. So we have to add print to it to control the thermal performance. But what's quite unique about our prints, so this is a picture of the top of a skylight and the underside. On the top, those prints are providing shade and reflecting the heat, but on the underside, they've basically disappeared. You still have that connection with the sky. And we're able to control the thermal performance by the intensity of the print, so like light, medium, dark, and the geometry, how much it covers. And from that, we have a range of tables that our facade engineers and environmental engineers use. And we often give the advice on what is the solar heat gain, the U values, the light transmissions, all of that data we have. And we can customize it to what you need for your location, for your application. We also can have different numbers of layers, and this is unprinted ETFE values. If you put a layer of print on top, you can be down in the low ones for U value, but essentially 2 layers of ETFE, you're going to get very similar values to double glazed, low E, fritted double performance glass system. We add 1 more layer and you're into triple glazing values, but we only added 1 kilogram per square meter. So the ETFE itself with the frame averages about 7 kilograms per square meter. As I said, if we add another layer, that 7 becomes typically just 8 kilograms compared to 40 to 50 kilograms for performance glass. There are a range of colors that can be added to the ETFE. And longevity. So this is one of our first roofs, almost 40 years ago. Samples have been taken from that roof, and the ETFE basically hasn't changed mechanically or chemically. So we couldn't really extrapolate an age because it didn't age. So the ETFE, if you've got a 50-year lifespan, 60, 70, the ETFE is going to be there, that lifespan of the building. The material, so ETFE is basically almost like the big sister of Teflon. So your self-cleaning finish. So what you have is a non-porous surface. So if dust, construction debris, whatever, gets on your roof, heavy rain is cleaned. So a big, big advantage with the ETFE is really the low maintenance side of it. Fire. So what's wonderful, especially with the internet, look up fire and ETFE. You don't find anything. You'll find the good points. You will not have anything negative. ETFE, as I said at the start, is a fluoropolymer. So if I can't expand this, but if you look carefully what's happened here, we have a plume of fire. That's probably 6,000-7,000 degrees. The ETFE has moved away from the fire, self-extinguished, and made a smoke vent. There's no dripping, there's no fumes coming off this. So what we have in Singapore as an example, we have what's called the product listing scheme. So these are, you have to do a whole bunch of testing, and then all of what we would call locally QPs, qualified persons, but your architects and engineers, can pick any product off that list and not ask permission from any authority. So our ETFE is on there, and the key part here, for those who are very interested in fire, is the test EN13501, which sort of, since Grenfell Towers, everybody is finally focused on flame spread. And how this test works, if this was your sample, they actually put a fire on the edge of your material, and then they put cotton wool on the ground. And literally, if you get any burning embers coming down, touching that cotton wool, you're going to fail the test or have a much lower standard. But the days of putting like the old BS standards, they would take the material and fire flames at it, doesn't represent what's happening today with flame spread. So all of the testing, this EN13501 is a very good thing for the industry. So sustainability. So when it comes to transparent roofing and facade materials, simply there's nothing more sustainable than ETFE. So we have the EPDs, we have all of the certificates. If you're using LEED or BREEAM, tell us what you need, we'll help you. But you will not make a better choice than this. So I'm going to talk about two projects. So Barnager on campus. I have to start with the amazing consultants and project team that worked on this. This is one of the finalists for WAF with Safdie Architects. So hopefully you've seen some of these images. If you're not familiar, Sabana Jurong is the world's largest Asian-based consultants in infrastructure and urban design. It's about 16,000 employees. This is their new global headquarters in Singapore, home to about 4,000 people. Now, part of that design, there's the pavilions of the office blocks, and there's 3 courtyards. And over these 3 courtyards are 3 ETFE roofs. Now, what's unique is there's no structure. It's a first cable-supported ETFE structure in Asia. And what you're going to see, this is the top side view, and it's because the way a cable truss works is you're going to have essentially replace your steel truss and your steel beams. You're going to make a truss out of cables. So what we're seeing here is a cross-section of one of those roofs, about 30 over square meters. And the top is just made of 2 stainless steel cables, about 28 mm diameter, and a 32 mm at the bottom. On the top, secured to those cables, is a 4.2 meter wide ETFE cushion. And these are some of the outputs from the checks we do. We design the steel and the ETFE just like you would glass or concrete or whatever you're doing to the local codes. In Singapore, they're much more related to the European codes. And we're going to be looking at the worst case load combinations. Now, I want to jump into some of the construction. Now, what's interesting is you won't see much because the cables are so small, but we'll try and show you what's going on. So this is the roof we're trying to cover. Now, unlike steel, a cable has no form, it has no strength until it's fixed in place. So we do need a deck to support the cables first and support the ETFE. The prefabricated cables are all laid out, and then we use a special bar on the tower crane to pick those up, lower them into location, and fix them to the wall. So that's the structure. Those two lines is all you get when it comes to structure. Now, the key to cable structures is very high pre-tension. So you're going to pull those cables very hard so they don't move when the wind, because if a cable moves and bounces, it will eventually destroy itself. So there's a lot of work up front to get all of those loads into the concrete structure. It's something very hard to do on an existing building because the loads are so high. It's really something you would do on a new build. Here's a close-up view with that deck lowered. And again, all as you're seeing, one member, one cable at the bottom, a 16 mil tie rod, and then our extrusions on the top. Now, every single element there, the finish, the color, the shape, how the things are all selected and picked by Safdie architects. It's some of the most beautiful cable detailing in the world, full stop. This is the finished look, and obviously because it's a cable pulling on each other, you can't go that way. It's only always going to dip. Now, the things we worry about with the cables is not so much the up and down movement, it's the side to side, because if those cables start moving side to side, we get a lot of rotation on the perimeters, and that's very hard to waterproof. So we took advantage. There's a gutter here or a drainage channel collecting the water off the roof. We've took advantage of that to at least try and brace those members in the middle, the cables. And as I said, every single detail you can imagine has been through rounds of design and engineering with Safdies. I don't want to show, there's a lot of IP going on there at the top of those cables. Because if you can imagine, those cables are doing up and down and left and right. The waterproofing to make that work is extreme. But I think you'll agree, the finished courtyard, and it's not just the look, it's the feel, it's the acoustics, it's the connection with nature. Absolutely amazing. So I hope if you do get time, these are all public spaces. You can go to visit this project and go to all these spaces. So I'm going to finish with one more. Clark Quay, it's just finishing its enhancement program. Again, head down there, you can visit. Credit to the whole project team and the architects involved. As I said, the original development was Allsop Architects. Of course, the redevelopment has new developers and a lot of work with Atelier 10 on the thermal performance. So there's 18 angel roofs, making up about 10,000 square meters of ETFE. On the center, those are cushions to give the maximum thermal performance during the midday sun. And then a single layer just to help give protection from the morning and afternoon sun. Now, if you went there right now, you would not see those towers. Clark Quay is very much being developed with CDL and Capital Land with Canning Hills piers. So there's going to be a lot of connection of the public between these buildings. So Capital Land needed to enhance Clark Quay from a nighttime venue to a 24/7 venue. So they had to enhance the thermal performance right through the day. Now, we did a lot of work providing a lot of data to all the consultants to work out how do we not just make this work 20 years on, but another 10 years' time, because we all know urbanization's pushing up temperatures, climate change, all of these things we had to worry about. So the areas that are right above where you're going to sit, we had one of our prints which give a G value or solar heat gain value of 0.17. That's incredibly high thermal performance. For those not familiar, this is sort of double glazing, almost moving into triple glazing territory on a 2-layer ETFE cushion. And on the perimeter, we had a slightly lighter print because we didn't have to worry about the sort of 12 till 3 o'clock sun temperatures. Now, we were engaged to do one angel roof first, which is, this is the original pattern, and this is what we changed to. So you can immediately see it's darker, it's less glare, but I hope you notice there's more connection with the sky. You can see the clouds, you can see the blue sky, you can see the sun, even though we reduced the radiant heat by 67%. So you still kept that critical connection with the sky, but you were cooler. Now, what we also did, again, this is the existing roof, this is the new. We put on sensors at the start about 2 months before we changed the roof, and then for like 6 months after, so that Atelier 10 could check that their models and reality were working well. And they were really happy with the data. So existing and later, so from 12 till 3 p.m., as you said, 67% reduction, the whole space enhanced, and even a 4% drop in temperature at ground level. So how did we do this? It's an existing building. First of all, never trust your as-built drawings. They were pretty old. I think it was like AutoCAD 1 or something. So the first thing we had to do was actually resurvey that entire roof, because if we followed the as-built drawings, it would not fit. Now, the interesting thing was the ETFE installed over 20 years ago was packaged, sent away, recycled, and turned back into insulation for cables. So we fully tracked, full circle. So, everyone's talking about, this is real sustainability and real recycling happening on this project. The original ETFE had a new life as a different product, no wastage. Now, everything from Vector Foiltech comes pre-made, delivered in crates, so there's only assembly on site. You're not actually fabricating on site. So one of the first things we do is we always work in safety nets, again, part of what we do. It allows us to work at height. It's pretty, I shouldn't say the word idiot-proof, but if you drop anything, it's captured. If you're not thinking, you're always going to be captured. But on top of the safety nets, you're also always attached onto a lifeline. We clean up all of that steelwork. Again, make sure everything fits, put it in new extrusions. Our prefabricated cushions fit. You can see our installer was amazed. He was very happy that went in, but everything there was pre-made in Germany, based on surveys, installed, fitted in position. And there's a picture of it stripped, what it looks like now, and I hope you'll come and visit. And that's the end of our presentation. Thank you very much. If you have any questions, you need some technical support, we're just down around the corner. We have a booth, we have a whole team. Very happy to help you with your design questions, pricing, whatever you need from us. So thank you very much, really appreciate it. Thank you, Paul.